Okay, so this is the second homework on graphing exponential growth, but we're also it's focusing in on decay functions. All right, so on your other side, you have the steps. You want to identify your asymptote, all right? And your asymptote will simply always be, according to your tips on the other side, y equals your k value. And notice that there is no k value right here on the original, so it's y equals 0. So you know that when you graph your line, it's going to approach that y value of 0, that horizontal line. It'll never actually touch it. It'll just infinitely approach it. Okay, so let's actually go to step 1, which is make an XY table with consecutive integer inputs. Right there. From -3 to +3. We might not use all of them. Let's plug in the easiest one. Plugging in 0 is going to be 1/2 to the 0, which is 1. And then with the negative sign in front, it'll be -1. So when you plug in 0, you get the output -1. Are you with me? So let's go to the coordinate 0, -1. That's going to be down here. Let me do it in blue, since there is no k shift. I could now plug in 1, and then 1/2 to the 1 is 1/2, and then with a negative sign, it will be -1/2, right? Or I could use the growth or the decay factor, whatever your b value is, to get to the next output. So what's your b value right there, Sam? 1/2, right? Okay, so the b value is 1/2. That means it's a decay function. So I could use that decay factor and go -1 times 1/2, and it'll give me the next output. What's the next output going to be? -1/2. And then I could take that decay factor of 1/2 again to get to the next output, which would be -1/4 if you multiply by 1/2 again. 1/2 times 1/2 is 1/4. Now what would the next one be? -1/8. Okay. Now going backwards is not dividing by 2, dividing by 2, dividing by 2. Going backwards would be multiplying by 2, right? 1/8 times 2, that'd be 2/4, which reduces down to 1/4. -1/4 times 2, that'd be 2/4, which reduces down to 1/2. And then 1/2 times 2 is 1. What's the next one?
Are you ready?
The next one is 2. And the next one? And the next one? We're talking about negatives here. They're all negatives. So that is all the coordinates that we need. Let's start graphing them. Let's go to we already graphed 0, -1. Let's go to the easier ones. I don't want to deal with fractions yet. -1 and half. So -1 and half is right, -1 and -2, not half. -1 and -2 is right here. And then -2 and -4 is right here. And then -3 and -8 is down here. Are you with me? Maybe you're not, because my iPad's frozen right now. Sorry about that. Now we already know what it looks like. Connect them. It's approaching, infinitely approaching our asymptote. So you don't even have to deal with the fractions. You could just start drawing it and curve it, and you actually make it seem like it's on the line, but we know it's not actually on the line. It just infinitely approaches. And that's your graph right there. Just put some arrows on it. And then you have to state everything you can. We already said that the asymptote was y equals 0. How about the domain? What's the domain? X equals all real numbers. How about the range? Is y above or below a certain value? It's less than 0. And now, what else did we need? The y-intercept. And you could say 0, a plus k. So that'd be -1 plus 0. So that'd be -1. Or you could simply look at where it crosses at 0, -1. And that's the answer to number 1. Should we try a different one or give you time to work on it? Okay, so number 2, I guess this is as challenging as it gets. Step 0, identify your asymptote. Asymptote is the equation y equals the k value, which is -7. And that tells you that whatever graph you do, it'll ultimately always be approaching, infinitely approaching that y value of -7. That's a horizontal line crossing the y value at -7. So here's my asymptote. I'm drawing it already. Step one is to ignore the k value. So step one is to box this in, make an xy table with nice integer inputs. So here's x, here's y. Let me do nice integer inputs, -3, -2, -1, 0, 1, 2, 3. We're not going to use all of them, all right? Let's plug in the easiest one. What's the easiest one to plug in? 0. Plug in 0 right there. What's 1/3 to the 0 power? 1. And what's 1 times 6? 6. So the tip I gave you on the notes side was, okay, so when you plug in 0, you get out of 6. And now you could plug in a 1, and then you'd get 1/3 to the 1, which is 1/3, and then 1/3 times 6, which is 2. But instead of doing all that math, you could use the growth or the decay factor, in this case a decay factor of 1/3, to take that 6 and multiply it by 1/3 and get the next output. What's the next output? 6 times third? That's 6 times, or it's like 6 divided by 3, which is 2. And then what's 2 times a third? That's 2/3. And then what's 2/3 times a third? That's 2/9. And you know what? These are kind of pointless because I already know it's getting closer and closer to 0. Okay? Let's go in the opposite direction. If from here to here I was dividing by 3, backwards would be what? 2 times 3 would give me 6. So what would the next number be up here? 6 times 3 is 18. Now that's already off the graph. I'm not even going to use that. So I'm just going to use pretty much these guys. The coordinate 0, 6, 0 on the x, 6 on the y, 1, 2, 3, 4, 5, 6 is right here. The coordinate 1, 2, 1, 2 is right there. And the coordinate 2 and 2/3, it's not even 1, is right there. And I know on the parent graph it infinitely approaches 0, which means it's going to look like this, right? Now, what do I need to do to these coordinates? What do I need to do to this parent graph? I need to move it where? I need to move this dot where? Do I need to move it 7 units down, right? Because it's a -7k value. So I'm going to take this, move it 7 units down. 1, 2, 3, 4, 5, 6, 7. And then I'm going to take this one and move it 7 units down. 1, 2, 3, 4, 5, 6, 7. Put a dot there. And then I take this one that was at the 2/3 of the way up and move it 7 down. But notice, this was the original asymptote on the parent graph. This is the new asymptote over here. So we already know that it's going to be right here, super close to the asymptote. That's why it's good to know your asymptote before doing anything else. And this is your graph. Just connect the dots. This is a decay function, infinitely approaching the asymptote y equaling -7. So let's state everything that we can. The domain, x equals all real numbers. The range, you're going to say y is what? Y is above or below a certain value. Y is greater than -7. We already said the asymptote. All we need is the y-intercept, the y-intercept. Now you could clearly see that it crosses right here at the coordinate 0, -1. Let's say you didn't want to do that. Let's say you want to do it with algebra. You could say plug in 0 for x, because we know to find the y-intercept, you set x equal to 0. And then you could figure out what y is, but it's going to ultimately be a plus k. Again, a plus k. That's a shortcut. So 6 plus -7, that is -1. It's easier to see. Oh, it just crosses right there at 0, -1. Anyway. Okay, so I almost forgot. Let's cross out the original parent graph, because that's not the one you want to represent. It's the blue one that's shifted 7 units down. Okay, let's check out number 3. Is this a growth or a decay function? Is it growth or is it decay? Is degrowth what? It's growth, right? How do we know if it's growth or decay? You look at the B value. If the B value is greater than 1, it's growing. If it's a fraction less than 1, then it's decay. Now, I know some of you thinking, oh, isn't that a negative 2? No, this is really the base 2 with the A value being negative 1. Okay? So we're going to just go do what we always do. Actually, step 0 is to state your asymptote. Simply y equals your k value 9. That's right. So I already know that whatever graph I get, it's going to infinitely... Oh gosh. I recorded that. So our asymptote is at 9. So we know our graph is going to infinitely approach that dotted red line. It'll never actually get there. It'll just infinitely approach it. Now with the XY table, we need consecutive integer inputs. I always like to use -3, -2, all the way to +3. And then what I like to do is plug in the 0. And when I plug in 0, and by the way, we're ignoring the k value for now. I plug in 0 for x, and I will get 1 because 2 to the 0 is 1, but then the negative in front makes it -1. Does that make sense? So at this point, I could plug in another 1 right there and get an output, plug in 2, get an output, plug in 3, get an output, or I could use the B value, which is 2 in this case. That means it's a growth factor, and I could take -1 and multiply it by 2, and I'll get -2. I could take -2 and multiply it by 2, and I'll get -4. I could take -4 and multiply it by 2, and I'll get -8. Does that make sense? Why are we multiplying by 2? Because the base is 2. If the base would have been 3, I would have been multiplying by 3 and gotten a 3 and then a 9 and then a 27, right? But it's 2, so I'm only multiplying by 2 as you go down. Now, as you go backwards, it's dividing by 2. 8 divided by 2 is 4. Actually, -4 divided by 2 is -2. Divided by 2 is -1. Divided by 2, what's the next one up? -1/2, and then -1/4, and then -1/8. Now, you already know that it's infinitely approaching that red dotted line, the asymptote, okay? But that is the final graph, the asymptote. Right now, we're just dealing with this blue boxed-in portion of it, which is the parent graph, and the parent graph has the asymptote at 0, okay? So let's start graphing these guys, and remember the parent graph asymptote is at 0. So we have 0, -1, which is right here. We have 1, -2, which is right here. We have 2, -4, which is right here. We have 3, -8, which is down here. And we know that it's growing, but in a negative direction. Now, in the opposite direction, if you go to -1/2 and -1 and -1/2, you'll be right here. If you go to -2 and -1/4, you'll be right here, closer to the x-axis and closer to the x-axis. So you know it's pretty much, you draw it like if it's touching, but it never actually touches, just infinitely approaches. But that's not your graph. Your graph should be infinitely approaching the asymptote up here of y equals 9. So we're going to shift all of these coordinates up there. Okay. Is that confusing to you guys, of the shifting? So you could just shift every single coordinate. You see this coordinate right here? I want to shift it up 9 units. It's going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to put a dot right there. And then I'm going to move this guy up 9 units. 1, 2, 3, 4, 5, 6, 7, 8, 9. Put a dot right there. And then this one, I'm going to move it up 9 units. 1, 2, 3, 4, 5, 6, 7, 8, 9. Put a dot right there. Anyways, you shift them all up, and you'll end up with this graph. And we know that these halfway points that just keep getting closer and closer to the asymptote, you're going to draw it like if it's actually touching the asymptote. Now, that's it. You don't worry about that one. Put X's on it. And you need to answer everything else. Now, if you're getting confused with shifting your parent graph up to the top, here's another way of shifting. Instead of visually shifting by counting, you could actually take all your y values here and simply add 9 to them, and you'll get your actual coordinates if you wanted to. Okay? So for example, if I wanted to, I could take the coordinate 0, -1, add 9 to it, and it'll be 0, 8. And if you did go to 0, 8, 0 on the x, 8 on the y, you'd end up at that point on the final graph. Does that make sense? Or, so if you wanted to, you could add 9 to all your y values. So this coordinate would be 1, 7. This coordinate would be 1, 5. This coordinate would be, 2, 5. This one would be 3, 1. So your y-intercept would be 0, 8.
So every time you shift, do you have a new graph?
Yeah, you shift it 9 up, so you end up with your new graph. That's why I put 2 x's on the old graph, because that's the old graph. I don't want to grade that one. I want to grade the red one. Now, if the shifting confuses you, like I'm saying right now, is you could take your y values and add 9 to them. That way you'll get the 8, add 9, you get the 7, add 9, you get the 5, add 9, you get the 1. So you could get the coordinates, so you don't have to worry about counting. It's up to you, however you like to do it. So looking at this red graph, we need to state everything we know about it. What's the domain? The domain, x equals all real numbers. How about the range? Y is y, Sarah, is y above a certain value or below a certain value? It's below 9. It's below the asymptote. Y is less than 9. Okay, that's your range. The asymptote was y equals 9, y equals the k value. The only other thing we could do is state the y-intercept. That's 0, 8. And we got that by simply counting to see where it crosses 0, 8. That's it. Step 0. What's step 0?
Nothing.
Asymptote. So what is the asymptote? It's y equals the k value, which is -1. Okay, so what does that tell us? That tells us that at -1 on the y, I could actually draw that line. That's the asymptote, y equals -1. That way I know that my graph, which whether it's growth or decay, it's going to infinitely approach that asymptote right there. It's going to infinitely approach that asymptote. Now step 1 is to actually do the XY table. I always use the consecutive integer inputs from -3 all the way to +3 in order. Doesn't mean we're going to use all of them. We're probably not. Let's plug in the easiest one. What's the easiest number to plug in? 0. 0 right there. That's 1/4 to the 0. What's 1/4 to the 0? And what is 1 times 8? 8. Now remember, I like to ignore the k value. I like to get the coordinates to the parent graph, and then I shift according to k. So right now we said you plug in 0, you get out 8. Now the next one, I'm going to simply use this factor, whether it's a growth or decay. Is it growth or is it decay? Decay, because it's less than 1. So what I'm going to do is I'm going to say 8 times 1/4. That'll give me what? That'll give me 2. It's kind of like the problem we did on the front side of this handout. And then I could do that again and say 2 times 1/4. That'll be 2/4, right? 2/4. And that reduces down to 1/2. And you could do 1/2 times 1/4 again, and what do you get? 1/8. But see, at this point, you already know it's getting smaller and smaller and smaller to 0, right? Let's go backwards. In other words, 8 times 1/4, that's the same thing as 8 divided by 2. 8 divided by 4, you get 2. 2 divided by 4, you get 1/2. Going backwards, it would be times 4, times 4. So what's this next one up here? 8 times 4? 32. Now that's way off the graph, so I'm not even going to use it. The only ones I'm really going to use are these guys. I guess I'll use this one also. Let's do 0, 8. 0, 8 is way up here. 1, 2 is right here. And 2 and halfway up. 2 and halfway up is right there. Are you guys with me? Now we know that the parent graph, original one, if we ignore k, it's going to look like it infinitely approaches 0. But we know that that's not our real graph. Our real graph is to shift all of the coordinates down 1 unit. Are you with me? So you could actually do this visually, or you could do this numerically. What do you guys want to do, visual or numeric? Okay, if you say numeric, you're going to go to this 8, and you're going to subtract 1, so your actual coordinate is 0, 7. So if you go to 0, 7, it'll be right here. If you say numeric, subtract 1 from here, it'll be 1, 1. So you're going to go 1, you're going to go 1, 1, and that'll be your new coordinate. Make sense? So, but it's really easy to just shift everything down by 1. So I'm going to take this one and just shift it down by 1. That's my new point. And then I'm going to take this next one and shift it down by 1. And then I take this next one at the halfway point and shift it down to the next halfway point. And that'll be right there. And we already know that our final asymptote is y equals -1. So we already know that we draw it like if it's actually touching. So we don't want the red line, we want the blue line. Let's connect the blue line. And I would put some X's carefully on the red line above, not the blue line. The blue line is your graph. So now we need to answer some things about that blue line. What is the domain? X equals all real numbers. What is the range? Y is what? Y is above -1, which means greater than -1. Okay. How about the asymptote? We already started with that. The asymptote was y equals -1. How about the y-intercept? What's the y-intercept value? Set x equal to 0 and solve for y. So you could actually do the math. Set x equal to 0, that'll be 1. 8 times 1 is 8. 8 minus 1 is 7. Are you with me?
Yes.
Or you could just look at the graph and say, oh, this graph crosses right there, right here. Not the red one, the blue one. Crosses at 0, 7. So that's everything we could say about number 4. Let's take a look at number 5. So number 5, here's the general setup. What is the asymptote? Y equals -6. Y equals -6. So you could do this asymptote right now, or you could do it later. It's up to you. I'm going to do it right now. Y is -6. That's at -1, -2, -3, -4, -5, -6 right here. And it's this line. Now that's not our graph. This is y equals -6. This is the asymptote that our graph is going to infinitely approach and never touch. And then you go to your XY table, use nice ordered inputs, -3 all the way to +3, counting in order. We're going to plug in the easiest number. What's the easiest number? 0. Okay, so we plug in 0 right there. And keep in mind, I'm going to ignore the K shift. I'm going to ignore the K part. So when I plug in 0 right there, it's going to be 4 to the 0, which is 1. What is 1 times 1/8? 1/8. So when I plug in 0, I get out 1/8. Now, from this value, is it going to grow or is it going to decay? Is it going to get bigger or smaller? Bigger. Okay. So how do I go from here, this output, to the next output? It's going to grow by 4. So if I did say 1/8 times 4,
1/2.
that would give us 4/8, which becomes 1/2. So the output is 1/2 right here. And then if I wanted to get to the next one, I would go 1/2
1.
times 4.
That's 1.
And what does that give us? That gives us 2.
2.
And then if I wanted the next one, 2 times 4, what does that give us? That gives us 8. See how it works?
Yeah.
Now, is there any point in going in this direction? Not really, because you already know, oh, from 2 going backwards is dividing by 4 or multiplying by 1/4, and I get 1/2. Dividing by 4, 1/8, divided by 4, it'd be 1 over 32. And it's already approaching 0, right? This is your parent graph. So I'm only going to use these coordinates. Let me do these coordinates in blue. So 0, 1/8, 0 on the x, 1/8 on the y is right there. It's close to nothing. And then 1 and 1/2. And then 2 and 2. 1, 2, 1, 2. It's right here. And then we have 3 and 8, which is up here. This is a growth function. From left to right, it does get bigger, but we already knew that because the base is bigger than 1. Now, in the opposite direction, we already know it's going to be decaying down to 0. So I could put the dots here or just say that my asymptote is right there at 0 on the parent graph. Now, I don't want the parent graph. I want the actual shift with the minus 6. So I need to move all of this down 6. Now, notice that the asymptote, I already started with that. It's already shifted down 6. But I need to shift this point down 6 and this point down 6. Or you could do it numerically if you wanted to. You could say that your coordinate, right here, this coordinate, 2, 2, you could say that if I were to shift this one down 6, it would give you 2 comma negative 2 if you shifted it, no, 2 comma negative 4 if you shifted it down 6. Or you could just simply count shifting down 6. So this one down 1, 2, 3, 4, 5, 6, put a dot right there. And then this one we go down 6, 1, 2, 3, 4, 5, 6, put a dot right there. And then the next halfway point goes down 6, and it would be right here at this halfway point. And of course, you know it infinitely approaches that asymptote. You draw it like if it's actually touching, even though you know it never touches. And connect the dots going the other way. Put an arrow, and there's your red graph. This blue one was your parent graph. Put 2 X's on it. You don't want to show that one as your answer. Whoops. Only the red one is your answer. And now we need to answer anything that's possible about this. What is the, what is the domain value? Okay, so the domain is x equals all real numbers, and y is greater than 6. Y is above the asymptote value of negative 6. So y is greater than negative 6. We already said the asymptote's y equals negative 6. The only other thing we could say is the y-intercept, and you could actually visually see it. That would be right here, but that would be at, that's a little more interesting. You can't really see it that well. The y-intercept is 0, comma, I would go with the numeric way of doing it, a plus k, 1/8 minus 6. 1/8 minus 6, that's going to be negative 5 7/8. That one's a little tricky. Negative 5 and, negative 5 7/8. Last one. Asymptote will be y equals what?
Y equals negative 9.
Okay, let's make an xy table. And let's plug in an easy number like 0 right there. And again, I'm going to ignore the minus 9. So if we plug in 0 right in there, that's going to be 1. And then 1 times 4 is 4. Now we're going to use this decay factor of 1/2. We're going to go 4 times half. What do we get? 2 times half. What do we get? 1 times half. What do we get? 1/2, and so on and so on. Backwards, it would be multiplying it by 2. So 4 times 2 is 8, times 2 is 16, but at that point, you're not going to use it anymore because it's already off the graph. So let's graph in red. Let's graph 0, 4, 0, 1, 2, 3, 4. Let's graph 1, 2, 1, 2. Let's graph 2, 1, or 1, no, I'm sorry, 2, 1, yeah. 1, 2, 1, it's right there. And then 3 and then half would be right here. And we know it infinitely approaches the parent graph asymptote, which is always 0. And going backwards, negative 1/8, that would be up here. So there's our parent graph. If you want to draw it, go for it. You don't have to. All you got to do is move those coordinates. Where are we going to move those coordinates? Down 9 units. So if I do take this top point down 9 units is 1, 2, 3, 4, 5, 6, 7, 8, 9. I'd end up right here. And then the next one down 9 units, I'd end up 1, 2, 3, 4, 5, 6, 7, 8, 9 right here. And then the next one down 9 units, you'd end up right here. And you know what? This is why it's important to state your asymptote from the start, because you know that it's infinitely going to approach y equals negative 9. So if you see those dots, you already know that it's going to infinitely approach the asymptote. So you just connect the dots and you're done. You're good. What is the domain? X equals all real numbers. What's the range? Y is greater than negative 9. And what is our asymptote? We already said it's y equals negative 9. How about our y-intercept value? 0, negative 5. Now count it. Check it out. Here's the origin is right here. So it crosses at, oh no, here's the origin. It crosses at 0 and negative 5. And that's all there is to say.